A check engine light is a nightmare to most drivers out there, and when they sit on their dashboard, they tend to run into panic mode. But do you know how a technician is able to know what is happening to your car when that light appears on the dashboard? Behind that light lies decades of innovation. Mulonji Steven is my name, and I'm the head technician at Nana Auto Diagnostics. Today I'll be taking you on a journey of OBD. We shall be able to identify how it started, how it became a global standard, and what it means for future diagnostics. So fasten your seatbelts and enjoy this ride with me. Someone out there may be asking, what is OBD? OBD is a standardized system which monitors and reports issues in the engine, powertrain, and emissions control systems. And it is that system that allows us to have access to control units and modules in the car. So before we go ahead and start talking about diagnosis, it is very important that we understand this gateway to those systems. That's why I have deliberately started with this system, because if we don't understand how it is configured and how it operates and what this system is designed to do, we will not be able to carry out our diagnosis efficiently. So at its core lies ECUs or modules. Now, these modules, they work with sensors, or they receive data from sensors, such as the oxygen sensor, the manifold absolute pressure sensor, also known as the MAP sensor, the mass airflow sensor, also known as the MAF sensor, the engine coolant temperature sensor, also known as the ECT sensor, along with other sensors. Now, whenever something goes wrong, a DTC will be set. Now, a DTC is a diagnostic trouble code, and it is that same code which will trigger check engine light and other lights on the dash. For instance, if the engine coolant is low, it will trigger that light. If the ABS is not working well, you see the ABS light. So it is that system that is responsible for that. So we really need to understand the OBD before you can even go ahead and start looking at diagnosis in general. So as I've told you, whenever a fault occurs, a DTC is going to be set. Now, for every DTC that is set, a freeze frame will also be stored. Now, a freeze frame is a snapshot of the engine RPM, vehicle speed, fuel trims, and other sensor readings that are captured at that time when that fault occurs. And this data is stored in the memory of respective ECUs or modules, such as the PCM, which is the powertrain control module, the TCM, which is the transmission control module, or the ECM, which is the engine control module. Before OBD became a global standard that we rely on today, it went through decades of trials, innovation, and regulation. Let's rewind to the early years and see how OBD has evolved as a system. In 1968, Volkswagen was the first car that had some bit of communication. Now, its communication, I would relate it to more of a whisper, because all it did was report some simple faults in emission control systems. But before 1968, all cars were 100% muscle and 0% brains. So a decade later, the Sun, also known as Nissan, joined and also started teaching its cars to talk. Their cars were embedded with an onboard computer that would report faults in emissions control system. This was just a glimpse into the future. It is also important to note that even though they were communicating, each was doing so in its own dialect. The areas of OBD were chaotic, and I would equate them to toddlers trying to speak, each one babbling in its own language. So what happened was, each manufacturer had his own standard. Therefore, mechanics and technicians had to acquire different tools for the different manufacturers. For instance, a GM, which is General Motors, had different connectors, pins, and scan tools, and Ford also had different scan tools, different pins and connectors. So if you are diagnosing a GM, it means you needed a different tool set, and the same applied with Ford. This confusion did not stop with the hardware, it cut across the software. Right now, if you retrieve a P0172 code, we know that that code means the system is too rich, meaning that the engine is running too rich, irrespective of the manufacturer. It can be a Benz, it can be a BMW, it can be a Nissan. It will always give you the same code. But back then, every manufacturer had different fault codes for the same problem. By the early 80s, cars could talk, however, each spoke in its own language. And I would equate this to having diplomats in a room with no translator. So it's like having so it's like having one diplomat from German and another one from Uganda. So one is fluent in German and the other is fluent in Uganda. So when you put them in a room, they may not understand one another, but each is fluent in his or her own language. So that is the same thing that happened. These cars, they didn't have a common language that would unite all the manufacturers, because their structure was based on OBD1. And the glorious days of OBD1 were shortened because of that. So let's look at the failures of OBD1. No universal data link connector. As I told you earlier, every car maker used his own plug and pins and also scan tools. Now the data stream was basic at best. So this system did give real-time readings. And then we had no freeze data frame, so you couldn't see what the engine was doing, and brand-specific scan tools only. Mechanics had to acquire different scan tools for every logo that was in the garage. So we had no universal scan tool. The California Air Resources Board, the Society of Automotive Engineers, abbreviated as SAE, and the International Organization for standardization came together and decided to make a standardized system which would cut across all manufacturers. And this system is what we know as OBD2. And these are some of the standards that we are agreed upon. We have the SAE J1850 communication protocol, which comes in two flavors: VPW, which is variable power width, and this was used by General Motors, and PWM, which is power width modulation, and this was used by Ford. Now these two standards describe two modes of communication: one, which is between the modules themselves, and two, the communication between the scan tool and the modules. We shall cover these in detail when we are looking at automotive communication networks. So if you have not yet subscribed to this channel, now would be the time to do so. And don't forget to hit that notification bell so that you'll be able to receive notifications whenever we upload new videos. The next standard that was agreed upon was the SAE J1962 connector, and this standard describes the pin layout of the OBD2 port, what most of you know as the data link connector or the DLC, commonly located under the driver's side dashboard, which allows scanners to retrieve diagnostic trouble codes and monitor vehicle performance. Now let's dissect these pins and see what is supposed to be on every pin. As I told you earlier, it's a 16-pin connector, and the pins which I have shown there are the ones which are standardized, and the ones which are blank are manufacturer specific. Pin number 2 is the SAJ1850 bus plus, and pin 10 being bus negative. Then pin number 4 is for chassis ground, pin number 5 is for signal ground, pin number 6 is for CAN high, and 14 for CAN low. Then pin 7 is the K line, pin 15 is L line, and pin 16 is for battery power. So that is the DLC, or what we know as the OBD2 port. These organizations also standardized fault codes, which we know as DTCs, into 4 main clear families, and they include the P0, which is for powertrain, the B0, which is for body, the C0, which is for chassis, and the U0, which is for communication networks. It is also important to note that the OBD2 system took off in the US, but was adopted in different parts of the world. So let's look at how this system was adopted and the name that was associated to it in the different parts of the world. So US was the pioneer of this system in 1996, and it went by the name OBD2. Europe joined in 2001 with petrol cars, and in 2004 with diesel cars, and it went by EOBD, which means European Onboard Diagnostic. And Japan joined the group in 2003, calling it JOBD, which is Japanese Onboard Diagnostics. And in 2006, Australia joined and called it ADR, which stands for Australian design rules, and India joined in 2013, also calling it OBD2, and later in 2020 they adopted a different name known as BS6, BS standing for Bharat Stage 6. What started as a simple tool to control emissions has evolved into this intelligent diagnostic system. Thank you for joining me. See you in my next video.